Thank you, Philippa. Hi, everybody. So, yeah, I'm Steve Pitt. I'm the manager of the Innovation Centre. I've been with Severn Trent 15 years next year. Just a few things to begin with. I apologise in advance if I use too many acronyms. I'll try to split up those. We do like, 3 or 4 letter acronyms to describe things. So, sorry in advance if stuff you're already aware of. But do put a note up if using too many acronyms or something. Just going back to the questions, as Philippa mentioned, anything I can't answer directly, I'll take away. We'll find the information where I can. So I hope people will see the bio about my background as a process scientist for the counties before I came involved with the innovation team. I was initially a sort of a technician on a temporary, sort of a trial when I came over to the Innovation Centre, but then I became the site lead basically, and I'm the Innovation Centre manager now. I've also got a couple of operators who work for me. We do sort of the operational wing of the innovation team, if you like. So we don't do things just at Spernal. We're part of a wider team, and we actually also look at water and waste infra and non-infra technologies throughout the whole patch, basically. But as I say, we're sort of the operational wing. We sit in the project manager team under a portfolio delivery side of asset intelligence innovation. So we're one section of a much larger team, but we are, as I say, the operational end, really. So I'll talk about what we've got going on at Spernal and some of the other sites as well. We've also had lots of visits here as well. We've had, I do numerous tours for all sorts of people. I've had regulators, sort of press people, the public, and everything in between, directors down here, all sorts of things. So I'm going to say, if anyone wants to visit or something, I also run those, so let me know on the back of it, I guess, basically. So, so we'll go on in. Next slide, please. Thank you. So just a bit of context. So starting a fair few years ago now in terms of strategy, there was a thought of looking at how much larger works at Severn Trent we have, different sizes of sewage works, basically ranging from like a small number of houses to like admin works, if you like, which drain half of Birmingham and all the rest of it. So there was a thought that some of these larger works, typically, if you split them into those that treat more than 100,000 population equivalent, there's so much sewage coming in that we looked at this sort of factory approach. So this, anyone familiar with Severn Trent in the past will know we did these brown papers, sort of like a thought shower, if you like. People scribble ideas and everything down. Lots of people were involved in this one. I like to use this actually, and this is on display at the Innovation Centre as a bit of a history type thing. You see on there, so we've got a big sewer pipe and also like a conveyor belt. That's how that's supposed to look. So it's thinking of the sewage coming in, because there's so much of it all the time and basically free as well. It's worth looking at all those things embedded in the sewage at such small quantities. There's so much of it. It's at a level that's worth recovering it. Things like, obviously, there's reusable water as part of sewage treatment, cellulose from toilet paper, more on that later. Things like biopolymers, phosphorus, nitrogen, so fertilizers in general, obviously methane, so embedded energy, some metals as well. So there's a lot of recovering some of those. So you're probably well aware of the circular economy principle, this reuse and everything, which kind of gave the place this resource recovery element, and obviously part of the naming as well. So not so much dealing with sewage as a problem and let's treat it, which obviously we still do, but it's a thought of what else is in there and is it worth looking at recovering it now, because there's so much of it coming on these larger works. So the larger works were grouped under basically an urban site, and so we'll talk on a bit later, but some of the early naming of this innovation centre was the urban strategy site, so I just wanted to put that into the context. Other things involved in it, not just resource recovery, things like network visibility, so obviously seeing what's going on in the network to control that much more, and obviously having a market for the products as well. So we mentioned the fertiliser, sort of the cellulose, all those kind of things. It's all like, what can we do with it once we recover it? In contrast to this, much smaller works, so things like less than your 2,000p works, and they drop down to, up into the small sort of septic tank sort of sites with 10 or 20 population contributing to them. they're trying to class them as this, what we call a rural strategy, rural vision, which we want to be much more passive, so have far fewer visits from the person in the van, that kind of thing, much more off-grid sort of community spaces. An example for that, some small sites get a phosphorus permit imposed on them because of where they discharge into. So ideally, we'd like to go away from having to put it like a chemical dosing infrastructure in those sort of environments. So a much more holistic kind of view. Because obviously, if you set up a chemical dosing installation, you need to get more tankers to go, and so on. It kind of spirals. So something that we did here at Spernal was look at what's called reactive media. So it's changing from normal reed bed gravel to a media that naturally absorbs phosphorus. That's just one method we do, looking at some rural strategy stuff. But the stuff at Spernal is mainly about the urban vision. So there's two ends, broad ends, two ways of dealing with the issues of these sites. So this site was based on the urban vision, so this whole resource recovery element. And next slide, please. So this was basically lifted from one of the early documents that explained the sort of background of this place. So, so the aim of the project was to deliver against PR14, so that's when it started, to deliver against that business plan, to deliver an urban wastewater strategy site and trial new technology likely to play a role in capital planning for AMP8 and beyond. So there's the reference to the urban wastewater strategy site. That's what it was called initially. So specifically then, it enabled the construction of the infrastructure necessary to facilitate plug-and-play ability for containerised or bespoke technology trials. That's pretty much what we ended up with. And it was agreed to locate this facility at Redditch, Spernal Sewage Treatment Works. Trying to move away from just saying Spernal because a lot of people don't know where that is, even people in Redditch. So I always say Redditch, Spernal. It's one of those, a lot of our sites have two names. Locally, Spernal, as I say, not everyone knows where it is, so Redditch, Spernal I tried to go to. So, could the next slide, please? Bit of a background of why Spernal, or Redditch, Spernal. So this little flow diagram from the early publications. So it's quite a history of innovation at Spernal, Redditch, Spernal. So our ICA team are also based here. There are instrumentation control automation teams. They're the really clever people that deal with all the probes and so on, the integration of that in our systems and all the rest of it. And so in 2014, this became the first effluent factory. So we had, you see a small picture of it there, we had what's called a final effluent dashboard. So all the sort of probes and telemetry that we had on site, and what was introduced as well, came into a single screen dashboard, which you can see a glimpse of there, that allowed operators to have a one-stop check of how things were, to sort of prioritise visits, reduce sort of random visits, you know, target where things needed to be and all the rest of it. So a load of that was done here at Redditch Spernal, because, as I said, we've got the ICA knowledge here. So we had a load of probes and a load of integration of those, and they built the first dashboard, which is an amazing bit of kit. It's basically a massive screen with all the information, but straight away at hand. So this was a template for that. It's the first effluent factory here. Equally, we had a load of work done on the network. So we had intelligent pump stations. So these are, again, you can look at these monitoring on the network monitoring side of it, so an infra dashboard as well. And they show things like where a pump station is working particularly hard. You can see in the catchment which pump stations are at a higher level than others. So you can proactively call in extra pump stations, see those that are running at higher amps but sending less flow. So call for a proactive service rather than things scheduled, all that kind of thing. So much more visibility of what went on in the catchment. We had something called a ballard panel from a colleague of mine, something he designed to allow us intelligent control, basically. So it's a bit of a proactive warning of some of the network things. A huge visualization of what's going on there, which is obviously really important. And that was done here first. We also had some workspace trials done here in the early days. There's a picture there of a nice ramp up, but we looked at desludging options for the primary tanks. Because obviously we're a sludge processing site as well, to look at optimization of the sludge control, because we didn't want to keep sending water across to the sludge route, but obviously you want to maintain the optimal level of sludge in the primary tanks as well. So a number of things were looked at in the early days. So we had desludge pumps, the torque rating. This is to simply stop pumping when the product went thinner, things like that. And then we also had trials looking at linking sludge blanket detectors with the desludge timers. to control to an optimum sludge level. So all those things were trialled here and were quite successful, again, because of the knowledge that we had here, basically it's all sort of based. Shortly after that, we had the construction of the test bed, which is obviously the demonstrator site with the Innovation Centre now. You can see an early picture of it there. And then the trial sort of began in 2019, 2020, which brings us up to where we are now. So that's a bit of why Spernal. There was a lot of history around innovation, the ICA team based here, and trials are done before. There's also an area of site as well, which I'll look about in a minute. So if we get up the next slide, please. So I'd just like to put this on here. This was an early draft of what the place could look like. This is the concept of the Urban Demonstrator, so proper, like, you know, a block diagram type thing. So people from our engineering and innovation team basically got together and said, okay, what we want, literally a blank sheet, what kind of thing are we looking for our demonstrator site, our concept site, effectively. So you can see very early concepts and modular design. And the idea was, you can see at the left, sort of diverting some of the main site flow into these buffer tanks. This is a settled sewage and a crude sewage, sorry, and something labelled raw as well, more on that later. And on this little diagram here, we've got fixed assets, which I think they've highlighted in black, and movable ones in red. And we had someone actually refer to it as a caravan park for technology trials, and that kind of works, you know, if you're happy with that sort of concept. There's lots of underground services you see in the sort of yellow and orange coloured on here. There's various drainage channels and things all connected, and I'll talk about that later. But it's also got, we've also got our own chemical dosing and gas handling facility. So this was an early idea. Okay, what possibly do we want here? So you picture all the things in red that will come and go. All things in black are kind of the assets that are fixed. And yeah, if you want to call it a sort of a caravan park for dropping off things, that's absolutely fine. To the next slide, please, then. So this is a better version. So we gave the concept to some contractors to realise the vision, and obviously they came up with this, which is obviously a far better sort of diagram. It's a bit crazy to look at, but in summary, you can kind of see they've got highlighted here sort of 12 testing bays. So notionally, if you think of shipping containers, that's ideal. We like those. You know the size of them. They have it in and out. We can drop them off basically. So we like those. You can see also we've got our own modular building now. So we have an office here, a lab, training facility, meeting rooms and things. In the middle, you can see we've got a reinforced crane pad. So the idea is we can lift and shift a load of the units around by parking a crane there in the middle. We've got our own transformer and MCC, so we're quite separate from the main site. And running on the left is the existing road, so you can see you can sort of turn in here, and that's where we are based effectively. So yeah, that's just a bit of an example. So you click to the next slide, please. You can see it all in and how it looks now. So this was the name we came up with. So as I said, it was an urban wastewater demonstrator site, urban strategy site. It was locally as a test bed, test pad, all sorts of things like that. We settled on Resource Recovery Innovation Centre, shortened it to R2IC. There's a similar setup at a university in California, and they use the same sort of R2 sort of abbreviation. So it's kind of on trend with similar setups. Sort of much more catchy, and we've got a bit of our own, can't say branding, can we, but sort of identification really. We've got the R2IC logo on our PPE and the signage on site for anyone who's not been. So R2IC is now the address of the place as well. So this is like one of our promotional flyers effectively. So it is still our plug and play wastewater demonstration facility. You can see it nicely highlighted there when the concrete was shiny new. This is a few years ago now. You can see where it sits on the main site. It used to be the activated sludge plant. It used to be an ASP lane, but obviously it was disused and we built over it. What you can see, so you've got the old primary tanks and one of them empty, but you see the sort of the newer looking storage tanks. We've got two grey and one greenish sort of. Those are the buffer tanks that we divert main flow into. And this was the early days, so there's one, see there's two blue shipping containers, one on top of the other. That was one of the first trials. But you can kind of see how you then feed downstream into those units. That's basically a demonstration. The yellow area people parked is the crane pad. And you can just see our gas bag and our flare stack on this side before lots of things arrived. This is quite early doors, but you can see it as a bit of a, for context, basically, you can see nicely where things are, where things should go. Okay, we can move to the next slide then, please. And this is in much more detail. So that's obviously a model that was done by one of the designers. And again, you can see all sort of 12 bays full. The picture you just saw, there's only one bay occupied. This would be what it looked like with all the 12 bays full on here. So it's a dedicated wastewater research and development resource. So say me and the two operators, we only do innovative stuff. So there are always people here, and we're entirely focused on the innovation thing. So it's not as long as we can fit in, it's what we're here for. So it's dedicated for that. It's controlled, safe and flexible. So from the buffer tanks, we have flow control valves, so we can simulate diurnal flows, fixed flows, storm events, which is particularly relevant. We can suddenly change flows, suddenly stop flows, all these kind of things to test some of the trials. So we like to stress test things as well as obviously have the ability to call upon storms or diurnal flow at will. From a nicely mixed buffer tank, so we're not dependent on the weather or anything to do whatever trials require, which is really nice. It's all safe because everything that happens here, everything that happens on that image there, and sort of the nice gleaming concrete you saw, all gets returned to the main site inlet. There's a pump station in the corner that collects all the drainage and sends it back around Spernal main works. So that's quite unique. Usually we test things on live sites, but here all the effluent goes back around. So if we had a complete failure of a process, or even a containment failure or something, it would all go back around to the main works. We have probes in the effluent return station as well. So if it was poor quality, we can actually stop it going back around, stop everything, and dilute what's in there before it goes back around. So it's really unique in that respect. It's very, very safe. As I say, there are 12 testing bays. So you can put 12 sort of 20-foot shipping containers, if you like, or, you know, or 4 very long ones or something. It's all very flexible because we could cross-connect trials as well. We could trial a crude, like a primary technology and plug it into a tertiary one. You know, we can cross-connect things and we can use whatever feed source we wanted. So we spoke about the crude and settled sewage feeds. So we divert some sewage from the main crude inlet and also the primary tank as well, depending if you want crude or settled sewage. But we've got a tanker reception facility, the smaller tank that was in the picture. We can import anything via a tanker. So we've done trials with sludge, centrate, final effluent, leachates, even water. And anything basically you can bring in a tanker. And we can also create blends as well. We have the wash water, so the main site final effluent available. So we can do all sorts of blends of different things to be made and fed into whatever units. So it's extremely flexible that way. When it's full, it's equivalent to 3 small works, so 3 2,000 population equivalent works effectively. So it's the biggest sort of installation like this that we're certainly aware of. So we have a dedicated biogas handling facility. We do have a 20 cube gas holder and a flare stack and a vent, which is just connected to trials here. At the minute, it's taken up by one of the trials, which we'll talk about in a minute. And we have our own chemical dosing system as well. You can just see in this picture sort of closest to us with the white emergency showers, if you like, showing this diagram. So we can connect chemical feed to any of the feeder bays effectively. And because we expected to chop and change chemical depending on the trial, we have sort of IBC storage, not bulk storage options. So it's all very sort of dynamic. And obviously safe, as I say, it's all bundled and goes back to the main site anyway. We've got an on-site laboratory, again, dedicated to what we have going on here. We buy bits of kit bespoke for all the trials that are needed, as well as the general stuff we find in all the on-site laboratories. And talking about our links with ICA, we have an ICA training room here, where they have loads of their PLCs or whatever. I don't quite understand what they do, but they're on the wall blinking and look quite cool. So they have training sessions here as well. But we also have links to the Academy, Severn Trent Academy. So people come down here because Spernal site itself has a lot of the technologies, but obviously we've got the new things here as well. So move on to some of the academy stuff, which is brilliant. So, regarding the trials themselves, there's all sorts of different drivers for the trials. So we spoke about sort of resource recovery element side of it. There is obviously effluent quality tightening, just some general research things as well, but we also can just rent space on the pad to people. We've had some universities and some other companies just wanting a control testing environment, so we can just rent space for people as well. And there are also different trial specs as well. Each trial effectively has its own sort of, well, it is a trial agreement, a contract of what we're trying to get from it, who's doing what, and they're all funded slightly differently as well. And there are all sorts of range of development as well. Some of them are developed concurrently with us, some are partly EU funded. Let's say some of them are just simply, can we have a spot on the pad, please? Luckily, a whole other different department looks after all that kind of thing. But we also run trials on other sites as well, and other parts of the site. So when I go through some of the trials, we've actually got things all throughout Spernal, but all comes under us, the innovation side. It's all funded differently. Like I say, we have our own team. So yeah, that's a nice bit of context for everything. If you're happy to move on, then next slide, please. We'll go through some of the trials. So when it's basically ready to run, the first sort of concept, the early strategy, if you like, was broadly classed as sort of low energy. So this was something from a previous presentation. So the questions, can we build a sewage treatment flow sheet to truly energy positive? So how can we reduce the energy consumption of the treatment process, and how can we recover and generate more energy from the process? So this is a really early diagram of if you were to draw from scratch the sewage works now, what could you do? So you look at enhanced primary treatment. More on that slightly afterwards, but obviously the best load reduction, the best quality sludge sets you up for a good session afterwards. Anaerobic MBR, again more on that, but anaerobic mainstream treatment, and then the recovery of nutrients from that, and then optimizing sludge. So anaerobic digestion optimized. So ideally, this is how you can build a sewage works for the future. So that guided the early trials, basically, to looking at that sort of concept. So next slide, please. So breaking down the early trials, so obviously they sort of come and go, so sometimes they're in the, I'll be able to point to them, or if not, I'm able to point to where they were, if you like. So our first trial that you can see there was down as enhanced primary treatment. So it's a microflotation device, a version of a DAF plant. And you can see nicely in that picture how it was installed, connected to that one buffer tank. So that's the kind of the model of how the others have been. So this was a successful trial, an alternative to primary settlement tanks, which I'm sure you all know is just a gravity settlement process. It's been around for decades. Obviously, enhanced primary treatment, you reduce the downstream energy bands if you get more load out, and enhances the biogas production. So you click on to the next slide, there should be more on that. Thank you. So this was an example of what was used. So this was a microflotation plant. So it's a version of a clean water DAF, effectively. This used very, very small microbubbles, sort of 30 micron, and the human hair is about 100 microns, to give you an idea. And the actual process was developed for aquaculture. Although it's proven industrial applications. So we fed this with crude sewage, and the idea with this, you have this raft of micro bubbles that lift the sludge, which is then scraped off by a scraper. You can see in the bottom picture. So what we found, yes, reduced aeration demand, which had lower load going forward. We found equivalent removal in a much smaller footprint and very thick sludge. So that was a very successful trial. So the wins are obviously smaller footprint, less load going forward, and like thicker sludge. So if you think of the energy gain all round, that's quite good. This was the initial trial, was about 12 months. Successfully, I think it's one of the options now, and then we shipped it back. So this was the flagship one, the first one we did, enhanced primary treatment. So the next slide, please. So we have the largest anaerobic membrane bioreactor in Europe. So obviously anaerobic treatment potentially be a key enabler for energy neutral wastewater treatment and resource recovery. So this is a big trial, basically put us on a map. Effectively, this is part EU funded, very expensive, still running now. We took the whole one side of the pad. You click on to the next slide, please, to be more info on it. Thank you. So where do we start with this? So anaerobic MBR, so this is mainstream anaerobic treatment, because obviously a huge energy demand we have is adding oxygen to our activated sludge plants and things like that. So this is using anaerobic bacteria with a membrane bioreactor to remove the solids, which itself is a known thing. It works in warmer climates and industrial wastewaters. Here, we're not heating it, we're feeding it just with settled sewage. So it'll be a big game changer for AMP8 and beyond, that kind of thing. So this is Europe's largest one, part funded by NextGen. So this is a 500 cube a day. So again, a small work size. So I think it's the biggest one. So we're looking at challenges of the wastewater temperature being sort of obviously low. The composition, it's actually quite weak here for settled sewage anyway. And something we had was the methane is obviously in solution still being cold. So there's a separate membrane step after the bioreactor to strip the dissolved methane out of solution. So there are two sets of membranes for the ultrafiltration, and then there's 3M degas plant. So there's a trial involving all of those steps and getting all those bits of kit to speak to each other. This is a big collaborative effort because a lot of the bits of kit are available off the shelf, but integrating them and feeding them with what we were is a bit unique. So obviously we captured the biogas in our gas bag and measured it and all the rest of it. So it's all about the energy balance, because obviously all the membranes need cleaning, and then also the integration into existing assets. So it'll be a big leap from AMP8 and beyond. It's a huge part of our net zero, possibly net positive campaign, and it's still running now. This is our biggest and most expensive trial, still running away with our settled sewage at the minute. So I'm sure lots of people on the call that know more about this than I do on the science point of view, but in terms of operation, it ran quite well. There's some units offline now for a bit of retrofitting because it ran for the 12 months. So it's still here now for part 2, more optimization purposes, but that was a huge driver for what we've got. So next slide, please. So we have the membrane-aerated biofilm reactors. So these are in the main activated sludge plant. Again, part of the low energy side. So these are being trialled as a capital energy efficient alternative to newly extended activated sludge plants. That's a great picture. You can see it being dropped in the ASP there. So if you move on to the next slide, please. Just some more info. So there's an example of it at the top left, for those who don't know. So these use hollow fibre membranes to support and aerate biofilms. So what we do is sort of the opposite of a clean water membrane. You blow air down through these, like the image on the right shows, and an aerobic biofilm grows on the outside of these membranes. And these are currently sat in our anoxic zones. So it's known existing technology, but it's rarely used in this country, I think, anyway. So what we did, a side-by-side trial of 2 manufacturers of MABRs in our existing lanes, and we had the third ASP lane to run as a control. So it's very good to see 2 different manufacturers from the left and the right picture. Same idea, slightly different versions. So that trial ran for at least 12 months, looking at an extra bit of ammonia removal where you wouldn't normally expect it. So you're getting some ammonia removal in your anoxic zone, but also simultaneous denitrification. So the wins there potentially, it's a much more efficient use of aeration, I think, as not much is wasted, but obviously you have less load going forward into your other activated sludge part of the actual aerobic phase, so potentially you can save energy there as well. So that was a very good trial. Yeah, that ran for a while. We're now looking at process emissions linked to that as well. We'll come on that later. Yeah, for the next slide, please. So other sort of drivers then of the resource recovery, our net zero strategy, which is where we are now. So some slightly different drivers for some of these. So we've got cellulose recovery highlighted there. So this is exploring the quality and quantity of cellulose we can recover to receive 100,000 tonnes per year in Severn Trent for free of cellulose. There is an average usage of sheets of paper, which is obviously a quiz I often give to visitors, which raises a chuckle like what people think the average use is, but I won't go into that now. If you go on the next slide, please, we'll just drill down into this a little bit. So this is an existing technology from a company called Certec, designed for the recovery of cellulose from wastewater, so toilet paper. So the trial for this was just verifying the technical feasibility of recovering it, because it can be used as structural materials, so asphalt, concrete, and other building materials. So the bottom right picture is how it used to come out here. Again, this is quite funny for visitors, because gradually that would fill out there and then drop into a bucket. It was quite a low-tech sort of trial, and it only ran for about 8 weeks. Some of the trials ran for years, effectively. We're getting quite a good production of that stuff. We also imported different sewages into the buffer tanks for this one, because around the nature of the network and the sewer impacts the quality of the cellulose fibres. So obviously I have the indigenous stuff here, but we brought stuff in from other sites as well, so what different network characteristics did. As I say, it's an existing technology. It's a physical separation step. Uses various sieves and washers and things to basically recover. It's a surprise really, so what's been fed with the crude sewage always made through normal screens, but it still contains that much sort of cellulose, which is really interesting, really eye-opener. So a life cycle analysis estimates that you can improve the environmental profile of sewage works and reduce its greenhouse gas footprint by up to 15% if you employ these. So this is part of our sort of net zero going forward. It was a funny little trial. It ran for 8 weeks. It's quite amusing for visitors, but that was a good one. To say those recovery is something we looked at. Next slide, then, please. So another thing we're looking at, obviously, process emissions, which is obviously a big thing. So we had, again, the main ASP online N2O sensors to understand underlying causes, potential control of emissions. Yeah, obviously N2O, nitrous oxide is the most potent greenhouse gas emission associated with sewage works to do with nitrification, denitrification process. So look on the next slide then, please. So we were the first to install online N2O sensors in activated sludge plant. The idea was to understand underlying causes and find control optimization. To get a baseline, really, we had theoretical figures. These are dissolved nitrous oxide, though, so there's still a calculation to get the emissions factor, but there were calculations and assumptions based on what we were sort of producing, and these are given actual figures. So they always get a baseline data in like sort of an unaltered ASP language. So we did trials looking at fixing the DO set point, raising it, incorporating ammonia control, all sorts of things to see what it did to the background nitrous oxide. We've got 10 of these now throughout the whole ASP here. We've got them on other sites as well to sort of understand the level of risk, if you like, and what we can do to, what makes it worse, what makes it better. But what we've also tried to do is look at incorporating the existing sensors that we have. So we have obviously dissolved oxygen, ammonia, and some places we have ORP probes, and see if you can get a sort of surrogate indicator based on all those readings, what your N2O would be rather than installing these everywhere. So that's something we looked at as well. An exciting part of this now is a spin-off from the MABR trial is look at the impact of those units on the process emissions side for a number of reasons. It simultaneously nitrifies and denitrifies, so potentially you've got a step change there. But the off gas is also captured. So there's a hope that, and this is something we're looking at now, this current trial running, it will impact process emissions as well. So produce less N2O per unit of ammonia removed effectively. So that's the big thing we're really keen on. Okay, yeah, next slide, please. Which leads us into another trial we've got going on, very low tech one, so this is called N2O cover and treat, which is again covering part of the ASP. And this is trialling a photocatalytic cover effectively, sort of reduce emissions in situ. So that's a small part of the ASP, is a very small pilot to see if that would work. So if you scroll to the next slide, please, some info on that. Hopefully, I haven't got a brilliant picture of it. As you can see, that was where it's loaded, but it gives you an idea what the pilot scale looks like. So it's effectively a hood. The lighter patch is this titanium dioxide coated filter. So part of our net zero campaign, trialling the efficiency of active layer cover. So photocatalytic to regenerate in the sunlight. We aim to reduce nitrous oxide emissions, so it should convert them in situ, effectively using catalytic converter technology. So it's titanium dioxide and GAC. And the hope is, the idea is we could cover entire ASPs with it and convert nitrous oxide into less harmful things. I'm sorry, so that's a little trial we've got running now as well, part of our net zero campaign. Next slide again, please. And a slightly different lens, so this is an example of a sort of different driver, and this is basically rented space on a pad to another research team. Ice and water, please. So some of you, all of you may well be aware, we have our sewage treatment work sometimes these little crustacea that like to live in the final effluent. We essentially call them Daphnia or water fleas. Start wrong there, but you know what I mean. And there is a hope that there's a company looking at can they actually absorb some micropollutants. So these are slightly different species apparently bred somewhere else, and we have them in basically a small tank. We're feeding final effluent. So if you scroll on to the next slide, please, want a little bit more info about that. Thank you. So yeah, this company conducted a test trial of what they call patented technology, measuring removal of proxy chemicals, so measuring contaminants, if you like. So there's the pharmaceuticals, a few other bits and pieces, possibly phosphorus as well. There's a thought that these sort of absorb them. There's a hope that they do. So this ticks a few boxes, quite holistic, obviously, very, very low energy, you know, no chemical involved, just by sort of propagating sort of species that we often used to find. In a previous role, sometimes the Daphnia bloom when you find effluent could be a potential risk of your solids permit, things like that. So that's a very, very small scale trial looking at, one of the emerging contaminants or something would actually remove them for us. So that's quite a novel thing as well. And again, visitors like to see these because obviously you can see them zipping around a tank. Quite happy. So yeah, that's something that again we've run for a first part, sort of rejigging the sort of rig they're in now for the next part as well. So yeah, it's an exciting, sort of very low tech, but very interesting build trial as well. Another example of renting space on the pad, effectively that one. So if you can move on to the next slide, then please. So those are things we spoke about, what have been and gone, or what's here now, but these are the ones coming soon. Various stages of sort of development and arriving effectively. So in a particular order, so we have pyrolysis of screenings. So obviously our inlet screens here, we fill up a skip in about 2 to 3 weeks, which currently goes to landfill. We're looking at this unit next year, it'll arrive on site now, and we'll look at pyrolysing those screenings. So what energy can we recover from that? And obviously then have much less to go to landfill. So that's something that we will be looking at next year. So we'll also be looking at different sorts of screenings as well, because the sludge imports is compacted primary screening is all those kind of things. So we're looking at what energy do you get out of them and what's the residual sort of biochar and stuff to get rid of. So again, tick a few boxes, so energy recovery, but also less a landfill, so the environmental footprint as well. So that's something we're looking at. April next year, I think, is the current plan for that one. Ammonia recovery and hydrogen generation. So this is looking at the selection of ammonium hydroxide and follow on with electrolysis to generate hydrogen. This will be fed with centrate from the digested sludge liquors on site, using steam stripping effectively, and the science behind that I'm not 100% on just yet, but that's arrived on site, that's just been commissioned, and as I said, we'll be fed with centrate. Steam stripping will produce ammonium hydroxide, which is then being sent to a university where they will electrolyse it into hydrogen. So obviously, that ticks a few boxes. We've got hydrogen generation, so an energy recovery. I think ammonium hydroxide is used as a fuel as well. But treating ammonia this way, obviously you've got high ammonia in your centrate. It doesn't produce the process emissions part of it as well, so it ticks several boxes should it be working. So we'll see that. And actually, hopefully fire up next month or something like that, and run for a good while. So that'll be very interesting. Obviously, I've got to say, because it ticks a few boxes in recovering ammonium hydroxide and hydrogen. It's very good. A huge thing we've got dealing with later on this year is our treating CSO discharges and looking at storm scenarios and things. So we're going to have a storm generator built basically using crude sewage tank and modelling a final effluent tank as well, simulate different storm scenarios. So we'll have sort of some of the monitors will simulate a spill weir to look at modelling of that as part of the Green Rivers sort of campaign, and we'll also look at some pilot technologies that will treat CSO discharges on the spot as well. So obviously storm discharges is an issue. So that's a big driver from starting next month, and will take us a couple of years. We'll have basically storm generator and pilot trials for treating that. So it's again a slightly different lens, a different driver, if you will. But we're still having an aerial pad rented to another research company. So again, the next month or two, we're looking at what this company's looking at microbial fuel cells. So generating hydrogen again from pre-digestion sludge liquors though, and crude sewage, using electric currents and micro bugs that I don't really understand just yet. But yeah, that's something that we're looking at, helping them install and research that going forward. That'll be there a couple of years as well. So the whole thing should fill up later on in the year with all sorts of different reasons and different drivers for all these bits of kit. So me and my team, basically, our role in all this, so we make sure they're safe. We get the data that the technical experts want from the trials. So whatever sampling regime, whatever feed flow pattern they want, whatever telemetry, sort of probes, lab samples, all those kind of things. We do that for them, arrange the sampling, but also, I deal with the contractors, make them do safe, or do the installation and decommissioning that we can if it's small scale, all those kind of things. So that falls to me and my team to make all these things run happily once they arrive to the gate. Basically, they come out to look at. There's a whole different team looking at the strategy side about what we need to look at, but we look after them once they get here. So I think that's the last slide I've got. I think it just goes to any questions after that, if that's okay with everybody. Yeah, let me know your thoughts or any questions. I'll try my best. Thanks for listening.
There's a few questions on the chat. I'm not sure. Why is ANMBR instead of MBBR used? That's one of the questions.
So I'm not familiar with MBBR. The big thing about the anaerobic MBR is getting off their rated. So there's no, we're using the anaerobic bacteria. I didn't mention actually, one of the other wins from that is because we don't remove nitrogen and phosphorus in the process, the effluent stream is very, very clean of solids and BOD and COD and all the rest of it. The phosphorus and nitrogen is easily recoverable by ion exchange and things like that. I forgot to mention that part of it. But as I understand it, it's the anaerobic mainstream treatment, which is the unique part of that. I may be wrong, but I think that's the point.
Another question is, what brand of hollow fibre is presented in the slide?
Brand of what, sorry?
What's the manufacturer of the hollow fibre presented?
There's one by Oxymem, and there's one by Sewage/Veolia now.
Perfect. How will updates on these trials be communicated? Involved in a number of CSO projects currently, with many more to come off the back of recent media coverage. So quite keen to hear more about those. So yeah, especially interesting that one at the end when you were saying about the CSO kind of simulator was really interesting.
Yeah,
it's a big thing for most companies.
To be honest, it's something that we are constantly trying to improve on. So there is, so we should be part of a number of COPs and things, communities of practice. But the wider team are looking at spreading the message as best we can. So I know people are looking at it. Specifically how we do it, I'm not sure. But I think it's something we've identified as something that we need to constantly improve on, if you will, because even internally, not everyone hears what we're doing. So it's an evolving beast, I think, is a fair way to say. If any recommendations for that, I think we'll gratefully receive how best to spread things like that. I can ask our internal people for like an update. How are we doing with that now? Because I know it's something that we've identified as could always be improved on.
I think it's probably one of those things that obviously there's lots of stuff going on in the media for overflows. So I think it's just watch this space. We'll probably do an update kind of like later next year or the year after on where we are with some of these trials. So I think everything's kind of evolving. So the more we do, the more we'll kind of get to share later date, I think. So cool. Last question at the moment is the overall intent is zero emissions with environmental enhancement. I assume you have carbon emission expertise to confirm achievements on total life carbon impact. Also, what is the next stage to the innovation process and selection of scaling up CapEx and OpEx costs?
So luckily, there's a separate branch of the team looking involved in that. So the technical experts, sort of subject matter experts, are much better at that kind of thing than I am. So we supply them with the data that they need. So yeah, that's one of those questions I can take away and refer to a colleague over exactly all that kind of stuff. We're kind of the operational wing of that, really. So yeah, I can find a contact to answer those kind of things, but no, it's not. I'm not sure it's certain, to be honest.
I noticed one of the things you mentioned was obviously reducing greenhouse gases by about 15%. So using the cellulose. One of the things I noticed, you cover some of the ASP lanes. So what I've seen previously is by covering more on a balancing tanks, you increase the hydrogen sulfide. But I guess by getting rid of the cellulose, you're kind of less likely to cause any issues with sealing kind of gases in because you'll reduce some of the oxygen, like dissolved oxygen or whatever at source, kind of by removing some of these things, which will kind of make it a lot better. There's a lot of interesting technologies. Can you comment which ones are the most realistic to operate on treatment works? So I guess that's part of the trial, is working out which ones are probably viable, which ones are most
absolutely. So I should
cost benefit.
Yeah. So yeah, sorry, I should have said so. Before it comes here, it must pass what we call an FDV assessment, so feasibility, desirability, viability. So there's feasibility of the trial, is it desirable, do we really want it, and then is it viable? So one of the things we do as part of the trialing, we've got our O&M team, our internal team, look at what it looks like to operate and maintain going forward as well, to give it the overall balance of sort of people, time, and cost. As well. So everything has to have that assessment that forms part of the overall trial. So the MABR units have basically been adopted as going in a few places because that was all sorts of ticks effectively. The ANBR was still looking at the chemical optimization part of that, because that required really stable operation to optimize the chemical clean, and that's the part we want to look at going forward to fully close off what that looks like in an overall energy balance. You know, there's no good at producing really good gas. You have to clean it every week and use a load of chemical. So that's the part that we're sort of looking at in the next phase, effectively. No, this O&M and FTV assessment all form part of everything. You know, it may work, but is it feasible? We have, for instance, looked at some very low phosphorus trials, which I didn't talk about on here because it's kind of sort of not needed now, not really future-proof, because you use a load of chemical. So it did work, but it was an expensive use of chemicals, so it wasn't, it wasn't a huge sort of success to tick the O&M box, if you like.
Oh, perfect. I think we'll probably call it a day there. So I think the time's expired, but it's really, really good to kind of see what's going on. Really interesting to see. So yeah, so I think we'll probably close it there. As I think probably mentioned earlier, we've got the Severn event in Our Street Park on Wednesday this week. So we are looking at doing one in Mansfield next month. And then we've got the event for the citizen science at the beginning of November. So yeah, thank you all for your time. Thank you, Steve, especially. Thank you, Philippa, for organising. And yeah, just thank you so much for your time, guys.